Hello, I'm Pallavi Bhagdev from Pune. Today we today we will discuss on topic is that semiconductor. This chapter is related in our 11th standard in physics. So before we go into a semiconductor topic, we have briefly idea about that. In our day-to-day life, we have used many materials. That some are insulators, some conductors, and some are semiconductors. So today we detailedly discuss on what mean by a semiconductor. Further going to that topic, we have know about that. What mean by a valence band and conduction band. So valence band is that band that is our outermost valence shell. Outermost band is filled with an electron. It is called as a valence band. And conduction band is those it is the further band next highest band of a valence band. So here it is maybe partially empty of fully filled with electrons. So question is next is that what mean by a gap? A gap means that the difference between the valence and conduction band. It in between the gap it is called as uh, forbidden gap energy. So further topic is that a conductor. A conductor whose those material which have a capability to flow of electrical a charge. Uh, the material is easily to allow the electrical charge. That is called as conductor. The conductor having the examples are copper, aluminium, silicon, uh, are the best example of good conductors of electricity. So in this diagram, we have seen that valence and conduction bands are overlap with each other. Here is a no forbidden gap between them, and we see that in this diagram we see that uh, some of the electrons are easily passed to the conduction band. Easily pass through conduction band, and there is no forbidden gap between them. That material is called conductor. And the next is an insulator. What is the insulator? The material which does not allow the flow of electrical charge carriers or current. That is called as insulator. The insulator having the example are wood, glass, ceramic materials are the best example of insulator. Insulators are also called as poor conductor. There is no capability to flow of current. So it is called as insulator. So here in this diagram we see that the valence band and conduction band having a maximum distance between them. I think no, it is the band gap is that it is a greater than 3 electron volts in the insulator. This is a greater than 3 electrons volt in insulator. Then next is a semiconductor, the material which has an electrical conductivity between the conductor and insulator. They easily the conductivity is the lies between the semiconductor having electrical conductivity lies between conductor and insulator are called a semiconductor. The best example is silicon and germanium. Uh, there is a maximum use of a silicon and germanium atom, and also the example is graphite. So, in this diagram, also we see that there is a small difference between valence and conduction band. But here we see that the valence bond is almost full, but a conduction band is empty, almost empty. And this forbidden gap is less than 2 electron volt. 2 electron volt. This is a detail see in this energy diagram. So what is the most important topic of the semiconductor is that uh, The energy bands of semiconductor can be defined as the material which have a almost empty conduction band. We have already I have already told you that the conduction band is almost empty and band is almost full. Then next is that the energy gap is a very small. I have told you that already told you that even a thermal energy at room temperature is enough. Means that here is a not a need of any external heat. By rising the temperature, the more electron will be transferred to a conduction band. So here we see that when we increase the energy of semiconductor materials, they then the most of electrons are passed through the conduction band. So when we increase the temperature of the semiconductor material, uh, the when we increase the rising the temperature, more and more electron will also be transferred into the conduction band. The process result in possesses in conductivity. When the material having arises a conductivity, then also increasing the temperature. This is a simultaneously means when the conductivity is increases, also the temperature is increases. These semiconductors in a periodic table. This I think it is a very helpful for everyone to understand what is a trivalent impurity and what is a pentavalent impurity, and what is the location of the silicon and germanium of semiconductor in the periodic table. So here we see that this is a trivalent impurity. Third A group element boron, aluminum, and gallium are the trivalent impurity, and here we see that the silicon and germanium are a semiconductor materials, and that is a phosphorus, arsenic, antimony, nitrogen are a pentavalent impurity. So here the types of semiconductor. A semiconductor having a main two types: intrasonic semiconductor and extrasonic semiconductor. So here the intrasonic semiconductor is pure form of semiconductor. In this, I have already told you that the example is germanium and silicon. And in this intrasonic semiconductor, the number of electron is equal to number of hole. And in extrasonic semiconductor, having a N type and P type. This discuss will later on. Firstly, we discuss what is a intrasonic semiconductor. Here, the intersonic semiconductor is a pure form of semiconductor. Uh, Here is no required any doping material. It is a uh, pure form of semiconductor. The example is germanium and silicon, and having a band gap of a germanium is a 0.72 electron, and silicon is a 1.1 electron. The energy gap is small that even at the ordinary room temperature, that is a 0 Kelvin. There are many electrons which possesses a sufficient energy to jump across small energy gap between valence to conduction band. Alternatively, an intrinsic semiconductor may be defined as one of which the number of conduction electron is equal to number of holes. Means I have discussed about that. The number of in this intersonic semiconductor is a pure form. Here a number of electron is equal to number of hole. This is in this a lattice structure. We see that this is a covalent bond of silicon atom with each other. They are tightly bound with each other. When we apply some external heat to this semiconductor material, the, this uh, these covalent bonds are break, and one electron is moved. So here we see that the broken or covalent bonds and one electron is moved there, and here is arises some hole, free electrons, and it's a corresponding hole. Here we see that when we applied external heat, Sum of a holes are arises here. So and also the sum of the electrons are filled with that electrons. So here we see that a hole and electron, the direction, it is we see that the direction of electron movement. Here's the direction of electron and direction of a hole movement. The number of electron and number of hole is equal in intrasonic semiconductor. Extrasonic semiconductor is that a semiconductor having a admixture or a mixture of trivalent or pentavalent impurity. So when we pure form of semiconductor is added with trivalent or pentavalent impurity, so the had been added a extremely small amount of that is the one part of 108 are called as extrinsic impurity. The conductivity of semiconductor can be greatly improved by introducing a small amount of suitable replacement atom called a impurity. The process of adding the impurity atoms to the pure semiconductor is called a doping. Okay, this is the idea about the extrasonic semiconductor. So here is the n-type semiconductor. N-type semiconductor mainly due to electrons and entirely it is a neutral, majority electrons and minority is hole. So in this diagram we see that uh, we use a silicon. Silicon has a tetrahedral atom. Having means tetrahedral atom means having a 4 electron in outermost of the shell. Okay. So when we added, this is a pentavalent impurity. So pentavalent impurity means that in outermost cell having a 5 electrons. When this a pentavalent impurity is added to a silicon atom, they are bound with each other and one is a remaining there. That is a in this diagram we see that that is a one electron is remaining of free electrons. Okay. Pentavalent impurity, the phosphorus, arsenic, bismuth are the example of pentavalent impurity. Some are bound with each other, but one is remaining in that electron. The fifth electron of the dopant is a set free. Thus, the impurity atom donates a free electrons or conduction in the lattice. It is called as a donor. Now, this is called as a donor. And next is a p-type semiconductor. In this p-type semiconductor, um, here we add a trivalent impurity. The trivalent impurity we have already know about that. The aluminum, boron, indium, gallium are the example of trivalent impurity. Trivalent impurity means the outermost valence shell is having a 3 electrons. When the electrons are combined with this silicon atom, they are formed of some covalent bonds. But one is remaining to a bond with a silicon atom. That is that is a remaining of one electron. That is called a electron hole. That is called as a electron hole. So this is called as a p-type semiconductor. In this, the majority is a holes and a minority are electrons. And in this energy diagram, we see that the acceptor level is nearest to the valence band. And in n-type semiconductor, we see that the this is a donor level is nearest to the conduction band. Okay, so this levels an absence of electrons of hole in the impurity. These impurity atoms which are ready to accept a bond. So it is called as acceptor, and n-type semiconductor it is called as a donor. Okay. Hope so everyone can understand this concept. This is a very interesting topic to understand. Uh, so, according to this is a discussion about semiconductor and their type, intrasonic and extrasonic. So, what is the main differences is uh, that is I show you intrasonic semiconductor and extrasonic semiconductor. So first is that the intrasonic semiconductor means it is pure form having density of electron. I have already told you that the density of electron is equal to density of hole, means number of hole is equal to number of electrons, and electrical conductivity is low. It is I am focusing you that electric conductivity is low. In that reason, it is not useful in practical purposes because it is not beneficial for any practical. But extrasonic semiconductors having electrical conductivity is high. It is very useful for practical purposes. Okay. And here, intrasonic semiconductor is depends on temperature only. But in intrasonic semiconductor, it is not depend only a temperature as well as the amount of impurity. Intrasonic semiconductor is no impurity, and extrasonic semiconductor has trivalent impurity and pentavalent impurity. So important properties of semiconductor. Already we have discussed about all the things, but briefly I have revised that what is the important point of the semiconductors, and that is also called a property. The semiconductor acts like an insulator when it is at a 0 kelvin. A 0 kelvin means that at a room temperature. On a increasing the temperature, it's work as a conductor. Okay, so it is act like when at a room temperature we have no need of any external heat, so it is act like a insulator. But when we increase the temperature, it is act like a conductor. It is a less power losses. Then next is the semiconductor are smaller in size and possesses a less weight. So uh, due to that reason, it is a very widely used uh, in electronic purposes, in many electronic devices. The resistivity is higher than conductor but less than insulator. Okay, I hope so. It is understand this is everyone. The resistivity is higher than conductor but less than insulator. The resistances of semiconductor material decreases with increasing temperature. Okay, this is vice versa. Means that when we decrease the temperature, the resistivity is increases, and when we decreases the resistances, the temperature is increases. Last but not least, it is a very important application in day-to-day life of semiconductor is that temperature sensor are made for the semiconductor devices, uh, 3D printing machines, using microchips and self-driving cars, using calculators, computers, and electronic computers and electronic devices. So, in this way, the semiconductor is very important for in our day-to-day life. Hope so all have understand this topic, and and everyone can understand this topic very good well. Thank you so much for giving me this opportunity to represent to me. Thank you once again. Thank you.